Hey guys, welcome to the second video in our 4-part series for our puzzle platforming game. In today's video, we'll be going over the player scripting and also setting up the interactions between the player and the door that leads to the next level. If you look in the last video, you can get a good overview of what we are going to complete by the end of this series, so make sure to go watch that video before you watch this one. In the last video, we set up our game environment and all of our entities, collision shapes, and non-scriptable components. So in this video, our main focus will be on scripting. Okay, now that we've gone over everything from last video, let's start by making our player scripts. So what we're going to do is we're going to come to our player here, and usually you would create a script for each entity, but in our case, we're going to create one script that's going to control both entities. So what we're going to do is we're going to go to our players folder, and we're going to go create new folder, and we're going to call this script. Perfect. And then in here, we are going to create a new script, and we'll call this player. Great. And now that we've created this script, we can now put this onto both of our players. And now when we add something to the script, let's say we add a class name and we call it player and save. If we go to our other player, we'll see that also updates here. And this is good for our use case because what we will be doing is controlling both characters at the same time. Having all of our player logic and interactions in one script for me seemed to be the easier option versus having two scripts that interact with each other. Might not be the best way, but feel free to leave a comment if this is not the approach that you would take. Another thing we need to change is to extend this to character body 2D, since our players are character bodies. And now we can get to coding. First thing we're going to do is set up our gravity, see if our physics collisions are working. So let's go func physics process, and then we will set our velocity.y to be plus equals 200 times delta. And what delta is just a timer that basically goes off when you press play, and it helps the physics engine mitigate against lag spikes or different refresh rates. So if we click play, oh, we got to do move and slide as well. And now if we click play, it works. Our players fall down and they land on the ground and don't fall through the map. Perfect. What we're going to do is we're going to create a thing called an export category, and we will name it player movement variables. And under this we will do an export var, and we'll call it gravity, and that will be a float, and we'll set it equal to 200 for now. This will probably change once we add in jump and everything, but that will do for now. So if we click play again, we'll see they fall, and now we have on our inspector tab 200 here. So if I was to go like 1000 and click enter, and now I press play, it should be faster. And you saw the blue player fell faster than the red player, and that's because of that export variable. So that's working properly. And now we can move on to the next step. Okay, before we set up any player movement with our keyboard, we have to go ahead and set our inputs. So let's open up our project in project settings, and we can go to input map. And I'm just going to create a couple here. So we'll create left, create right, up, down, and jump. And now if you come over to the little plus over here, you can go ahead and click this, and all you have to do is just click the key on your keyboard. So in my case, I'll click A, and it just automatically sets it for you. So you can do that for each key. Up, down, and then jump. Perfect. Now that we have our input set up for our keyboard, we can start creating our movement logic. So let's start by making a variable called direction, and that will be a float, and this will be equal to input dot get axis. What get axis takes is a negative action and a positive action. So our negative action would be left, and our positive would be right. And what get axis returns is either a -1, a 0, or a 1, depending on which key you press. So if you clicked left, it would return a -1. If you don't move, it's a 0. And if you click right, then you get a +1. So now we can say if direction does not equal 0. So that means if we have a key pressed down, we can do velocity dot x equals some speed, let's say 200.0, times our direction. And in our game, we're not going to be doing accelerated speeds. We're just going to, the second you press a key down, we're going to go at a constant speed just to be more simple. So we don't need to multiply this by delta. And also we want to say if we're not pressing a key, velocity dot x equals 0.0. So now let's click play. And they move pretty quick, but we can mess around with that. But if we collide into a wall, you can see they collide with the wall, they collide with each other. So that's working properly. And like our gravity, we want to have export var speed, which is a float, and equal that to maybe 100. Let's try that. We can replace that. There we go. Let's see if that's a little better. That feels good. 100. Okay. Now let's set up our jump. So we go if input dot is action just pressed jump. Then we want our velocity dot y to equal -300. And remember to do the negative because in Godot the upward y-axis is in the negatives. So if we click play now, we should jump. Yep, but the jump's too high. So let's up our gravity a little bit. I'm gonna say 1100. That should produce something a little better. Let's see. That looks better. I'm gonna mess around with the values a little bit till I get something I like, and you can do the same, but I'll show you what I put after. But how I test this kind of stuff is you get your unit blocks. So I have this singular block and set them up on the stage to test what you can jump over. And you want to make your jump reach the top maximum block. So in our case, we don't want our players to be able to jump more than 4 blocks. So if I click play now and I try to jump over the 3 blocks, I can't do it. And I also cannot do it on 4 blocks. So if I come along to our script and change our jump to maybe 330, now let's see if we can get over the 3 blocks. Now I can get up onto these 3 blocks, but I still cannot get over the 4, which is perfect. So our golden number, 330. And like before, let's go ahead, export var jump equal to 330.0. And then we can replace that. And if you want to keep tweaking it, now you can just do it in your inspection. Yeah, so that's feeling pretty good. Now that we have our basic movement set up, we can start setting up our animations. So let's create an onReady variable, and we'll call it animation sprite. And we will say it's an animation sprite and set that equal to, you guessed it, our animation sprite. There we go. And we'll create a function right after our movement slide called update animation. Okay, once you have your function set up, we can start creating the conditional statements to transition between our animations. So if not is on floor, and if velocity.y is less than 0.0, we want our animation sprite to play our jump animation. Else, we want our animation sprite to play our fall animation. And if we're on the floor and our velocity.x does not equal 0.0, then we want our animation sprite to play walk. else we want our animation sprite to play idle. So if we click play now, this should work. So if I move, yep, walk into the wall, I jump, yep, that works. Now I go backwards and our animation sprites don't flip. So we have to fix that. So what I'm gonna do is I'm actually gonna create a variable called direction, which will be a float. And I'm gonna set this to direction. We can get rid of this. And now we can access this globally. So if we come over to our update animation, we can go if direction does not equal 0.0. So that means that a key is pressed down. We can say animation sprite dot flip h equals direction equal to negative 1.0. So this looks kind of weird, but basically what it's saying is this returns a bool value. So this will return true or false. So if it's equal to negative 1.0, it will return true, and we will flip our animation sprite. So when we click left, we want our animation sprite to flip, because if you think about it, he's facing the positive direction right now. So when we click the right button, that's the default sprite sheet. Now, if we click left, it will produce true, and we will flip horizontal. So I hope that makes sense, but now if we click play, you can see that works. And in the air it works as well. Perfect. Okay, now we want to start setting up our different player states. So the current state we'd be in right now is kind of our normal state, we'd say. That's where we can walk around freely and we're not stacked or carrying the other player. The next states would be if you stack on top of one another. And in mind loop, like we looked at in the last video, you're basically one character once you're stacked on top of each other until you throw your other character off of your head. But in our current state, that's not really working, and if we were to move forward, the blue character just falls right off. So we need to start setting that up. What we need to do is create a way for each player to detect whether it's carrying or stacked on top of one another. And we're going to do that using area 2Ds. So what we can do is we can go ahead and make a new area 2D node, and we'll call it top detection box. And we're going to give this a group name, and we're going to call it top detection box. And then I'm going to save this into components, and I'm going to give it another folder called top detection box, and I'll just save that in there. And then I'm going to attach a script, and we're going to put that in a folder called script. Perfect. And we're going to give this a class name, top detection box. I know it's a bit repetitive, but this is good practice. So now we can come over and make another area 2D, and we'll call this one bottom detection box. Go to node, group, add group, bottom detection box. And then we'll save this one into components, its own folder, bottom detection box, save, and then attach a script. Again, save it in scripts. I know it's repetitive, but that's what we gotta do. Script. And lastly, give it the class name, bottom detection box. Perfect. So now that we have those two set up, I want to come over to our collision layers, and I actually want to add another name. And we're going to call this detection box. And we're actually going to put our bottom detection box onto this layer. And we don't need a mask for our bottom detection box because we actually will not be needing to detect if anything enters it. So we just need it to be on its own layer so that our top detection box can detect it. So now, opposite to our bottom detection box, we can take this layer off, and all we need is our mask to be detecting our bottom detection box. So if we go up to node and we go to area entered, we can connect that to our top detection box. And under this, we want to go if area dot is in group, and the group we're looking for is bottom detection box. And to check if this is working, we go print, and we can say, well, now that we have our detection boxes on our players, we can actually use a property where we can go area dot owner. So the area's owner, which would be one of our players, and we can say owner dot name. So now if I click play, let's just check before we test this. So our player 2 is our blue player. So when we go to stack our blue player onto the red player in our inspection, we should be able to see that the blue player has landed on our red player. So, and yes, player 2 has landed. So that's good. That's working properly. Okay, now let's go back to our player script, and we're going to start setting up our states. So what we're going to use to keep track of our states is something called an enum. So what an enum is, it's basically a list of constants that you can set that can refer to different names of your states. So let's say I name my enum stack state, and I use curly brackets, and I'll have 3 states called normal, I'll have stacked, and I'll have carrying. And the normal syntax for enums is to have 2 capitals, camel case, and to have your states be capitalized. At least that's what I've seen. We also want to have a variable called current state, and that will be of type stack state. And we'll set that equal to stack state dot normal. Perfect. So our initial state will be normal, and that's when they're on the ground, neither stacked nor carrying. Something I like to do for debugging is to actually add a label. Make sure you do it to both. We'll call it state. And I'll just copy that. Go to player 2, paste. And then you can drag this into our physics loop. And you do state.text equals, and we can do grab our enum, and then we do dot find keys, and then we can put our current state in there. The output of this will go into our label, and it will tell us what state we're in. So if we click play, we should see that both of our are in a normal state. If you want to disable that, you can just use the little eyeball, but for now we'll keep that open. The next thing we want to do is change our states. So how we're going to do that is we'll come to our top detection box. So right now we just have it printing if a player stacks on top of one another, but what we want it to actually do is change the state of the player. So how we're going to go about doing that is we want to create an export variable and call it player, which will be of type player. And when an area enters, we want to create another variable, and we'll call this detected player of type player, which will equal to the area's owner. So the area that enters, its owner, which would be the top player, will then be set to this detected player variable. So what we then can do is once we have this, we can go player dot current state equals stack state, player dot stack state dot carrying, because this player is the bottom player, and we will then set the detected player dot current state, dot current state equal to detected player dot current state, or dot stack state dot stack. So what I want to do is come into our physics process loop. We're gonna have to change a couple things here now that we have states. So first thing I want to change is I want to say if not is on floor, then we apply our gravity. So right now our physics process loop works well for our normal state, but is not currently working for our other two states. So we can use a helpful thing called match, typically used with enums. So we can go match our current state to our different stack states. So go match current state, and then we will list out stack state dot normal. And for now, we'll just go pass. So now we can split up our physics process into each individual state. So I'm going to make a function for each state. So my first one will be process normal movement, and then we'll have one for each state. So I'll have one for stacked and carrying. So we'll do process stacked and process carrying. Now we have errors because we still need to declare the function. So let's go ahead and do that. I'll do it really quickly and we'll come back once we've written everything. Okay, now that we have that all set up, we want to make sure we're also passing in delta. I'll just copy paste this. There we go. So now we can go ahead and grab all of this code for our normal movement and paste it right into our normal loop. There we go. So if I click play, I should still be able to move properly in the game. Yep, and that's working. However, we switch into our other states. Now everything's broken. I can't move anymore. They're not listening to any input I give them. So now we have to start building out our other states. In our game, the carrier will be the one who's moving around and jumping and controlling. So we want our movement to still apply properly to our carrying player. The only difference is if our carrying player is in the air and presses jump, we want to throw the stacked player. So we can, for now, test this by going elif input dot is action just pressed jump and not is on floor. Then we can create a function called launch. And we'll just create that really quickly. Launch, which will print launch. Let's see if that works once we're in stacked. And we go into our stack state. You can actually see that we're able to move around with our player and he's following the movement of our bottom player. But if we click jump, we're actually stuck. We cannot move currently. So that's because our stacked character, let me go ahead and actually turn on debug shapes. So our stacked player is on top and is actually colliding with our bottom player. He's not moving, so he's kind of like a block because of the collision shape. They collide with one another, and since our stacked player's process function has nothing going on in it, he does not move no matter what we do. So he's basically like a barrier. So we actually need to fix that before we can test the launch. So what we want to do is we actually want to have access to our players' body colliders. So that will be our collision shape, which we'll set to, again, our collision shape here. It'll also be useful for us to have access to the other player. So we can say partner, call partner, and which will be a player, and we'll just set that to null to start with. So let's come back to our top detection box here, and I'm gonna split this up a little so it's more readable. So we'll put a comment saying top player, which will be anything that's our detected player, and I'll also have our bottom player. Okay, so we then want to set our partners. So detected player dot partner equals player, and our player's partner is equal to detected player. Let's come back to our player state. I want to create a function. We'll call it disable body collider, and it'll take a value of bool and return nothing. And what we'll do is we'll take our body collider and we're going to use set deferred. So I know you can access .disable just by using its property, but if you set it to true or false, it just doesn't work. I don't know why. I've looked it up online, but set deferred works. So you go disabled and then you do value. So we can now have a function that disables our body collider. So we can come back here, and before we were getting stuck on our player, so we can actually go detected player dot disable, let's save first, dot disable body collider, and we'll go true. So now if we press play, let's see what's happening. So let's stack. Oh, okay, so that's a problem. So what's happening is our player is no longer colliding with anything because we disabled its body collider, so it's just falling through our other player, and then it's actually disabling our other player, and they're both falling through the map. So that's due to this velocity here. So how we can combat that is we come to our process stacked movement, and we can go velocity equals vector2 dot 0. So now what happens? Okay, so now this collision is disabled, but he no longer moves with us. So let's try something else. So if our partner is not null, then we want our global position to be equal to our partner's dot global position. So now what happens? Okay, he's inside of him now. So what I'm gonna do is create a node, and we'll use a marker 2D. And come to the move tool, and we'll move it a little bit above his head. We might have to tweak this a little bit, but we'll do that for now. And we'll also paste that in here. So now if we click on our script and we create another onReady var, and we'll call it head target, which is a marker 2D. We can come down to our process carrying, or sorry, we can come down to our process stacked, and we'll go partner dot head target dot global position. And now let's click play. And now we have it working. So our player's on top. We can now jump with our player and move around. So that's awesome. All right, so let's come down to our launch function and start setting this up. So when we launch, we want to be launching our stacked player. So we're doing this from the carrying movement process function. So that's going to be our bottom player. So what we want to do is actually take our partner and set their velocity.y to equal our jump speed. Don't forget to put the negative there. And if partner, so if our partner's not null, we want to set our partner's current state to equal normal. We then want the top player's partner to be equal to null. And then we want to also take our partner's body collider and actually enable that. So we'll set that to false. And I'm just going to comment top player. And then below, which is our bottom player, we want to set our current state to also equal normal and set our partner to equal null. And that should be good. So let's try that. That works. So the throwing function now works. Yeah, that's looking good. One other thing I notice is that our sprite on top is not rotating. So to fix that, we can just come under our partner here and we'll go animation dot flip h equals partner dot animated sprite dot flip h. So now if we press play, oops, now they turn with our player. That's all working perfectly. Awesome. If you experience any problems where you're jumping in the air upwards and you press jump and they're still colliding with each other in the air and resetting the state, then it's pretty easy fix. We can just go ahead and make sure we're disabling the bottom detection collider. So we can go on ready var and we'll call this bottom detection collider. This will be a collision shape. And we'll just set that to there. And we're gonna make a function really quickly called func disable. I'm gonna copy paste this and we'll just say detection collider, which will take a value of bool. And we will take our bottom detection collider and, like the one above, set defer, and then we'll do disable, and we'll do value. And I would just recommend doing this just in case you're getting weird collisions in the air. So you go like this, you go disable detection collider, true, and we can then re-enable it after a set amount of time. So we can call this activate detection collider, and we'll use a keyword called await. And what await does is it will wait for a certain signal to be called. So we'll do get tree and we'll create a scene tree timer and we'll set for like 0.1 seconds, and then we will call the signal timeout. So when the timer's done, it will then move to the next line where we can re-enable our detection collider. So we'll set that to false. So let's see what that looks like. Yeah, so that is working perfectly. The last thing I want to do is just set up our door script. So I'm going to attach a script here. Save this into the script file. There we go. I'm going to call this class name door. Creative, right? So we're going to attach two signals right away. So since this is an area 2D, we can add a body entered and we can add a body exited. And at the top, we want to set a variable called player count, which will be an int, and we'll set that equal to 0 to start. And if body is player, Then we want player count to have 1 added to it. And the opposite, when exited, if it is a player, then we want player count to minus equal 1. And we also would like to use a function called input, and if event dot is action pressed, and we'll say up, we want to up and player count is greater than or equal to 2. Then we will print next level. And then we will say if event dot is action pressed up and player count is less than 2, then we want to print cannot pass. Before we press play, let's make sure that our door has a mask on player 1 and 2 so it can see which bodies or areas are entering. So let's click play now. So if we have 1 player in front, cannot pass. Now let's get both of our players together. Next level. Okay, so that's working perfectly. That'll be it for today's video. In the next video, we'll be going over UI and level design. So if you have any questions from today's video, leave them below. Or if you have any other suggestions, also comment that below. If you enjoyed the video, leave a like and subscribe. And I'll see you in the next video. Bye.